So welcome students. So in this question you're given that you have a line y is equal to root 3x minus 3 and you have a parabola 2y square is equal to 2x plus 3. Now this line meets this parabola at 2 points A and B and P is a point root 3 comma 0. And if that is so what is the mod of PA minus PB? So first let us try to analyze the given question. So y is equal to root 3x minus 3. It is a line with slope root 3 and y-intercept minus 3. It's a very straightforward line. And if you have the parabola y square, 2y square is equal to x minus 3. Let us try to simplify this parabola. Let's try to convert this into standard form. So 2y square is equal to 2x plus 3. So y square is equal to x plus 3 by 2. Take 2 here. So what is this? This is a horizontal parabola. Y square is equal to 4x form. So it's a horizontal parabola. But instead of x, you have x plus 3 by 2. That means the vertex is minus 3 by 2 comma 0. The vertex is minus 3 by 2 comma 0. So if I draw this parabola, the parabola will be slightly shifted backwards because the vertex is minus 3 by 2 comma 0. And what is the point where this vertex meets y-axis? So if you put x is equal to 0, y will be plus root 3 by 2 and minus root 3 by 2. These are the 2 points that you have. Now have the parabola. Now have the line root 3x minus 3, y is equal to, and a point root 3 comma 0. If you observe closely, this root 3 comma 0 satisfies this line. This root 3 comma 0 is also a point on this line. Because if you substitute x is equal to root 3 into root 3, 3 minus 3 is equal to 0. That means if you draw this line, the line might look something like this. This point is nothing but root 3 comma 0, which is the given point P. And this line is meeting the parabola at 2 points A and B. Now you are asked to find the value of the difference between PA and PB. Now how do we do this? So one of the option is you try to find the point of intersections. Try to find the point of intersections A and B of this line and the parabola. Once you get the point of intersections, you find the length of PA, you find the length of PB. You can subtract them. It's one way, but there's a long way. There's an easier way for this using the concept of parametric form of line. So let us say that this distance is r. So let us say that the distance is r. Now we are starting from p root 3 comma 0. And what is this angle? Because y is equal to root 3x minus 3. The slope is root 3. That means this angle is 60 degrees. Now what is the general point on this line which is at a distance of r from root 3 comma 0? So a point at a distance of r units from root 3 comma 0 in the direction of this line. So in the direction of line is nothing but x1 plus r cos theta, x1 plus r sin theta. That is root 3 plus x1 plus r cos theta. Cos 60 is 1 by 2 and y1 is 0 plus r into sin 60 is root 3 by 2. So what is this point? This is any point at a distance of r units from this point. Now I don't want any general point at a distance of r. I want this point to satisfy this parabola. So I want such an r which ensures that this point satisfies this parabola because I want the point of intersections. So let me say that this point satisfies this parabola. That means 2 into y square, y coordinate square is 3 by 4 r square is equal to 2x plus 3. That is 2 into x is root 3 plus r by 2 plus 3. So if r satisfies this equation, then the corresponding point will lie on this parabola. So let me simplify this equation. So r by 2. So 3r square by 2 is equal to 2 root 3 plus r plus 3. 2 root 3 plus r plus 3. Now let me take the else. Let me send this 2 onto that side. So 3r square minus 2r minus 2 times 2 root 3 plus 3 is equal to 0. So now what are the roots of this equation? So the roots of this equation are nothing but r1 and r2 such that the points will lie on this parabola. So one of the root will be r1, this, one of the root will be this, and the other root will be r2. But as you can see from the diagram, one of the root will be positive, the other root will be negative. So r1 is, if I assume it as PA, r2 will be minus of PB. So if r1 is equal to PA, r2 will be having a magnitude equal to PB, but it will have a negative sign because you're going in the opposite direction. It is minus PB. So if you just want PA minus PB, that's nothing but R1 plus R2. R1 plus R2. So if you find R1 plus R2 of this equation, you'll get mod of PA minus PB once you take mod of this. So what is the sum of the roots of this equation? You know that it is minus of B by A. That is minus of minus 2 by 3. So R1 plus R2 is equal to minus of minus 2 by 3. So what is the formula I am using? Minus of B by A. So that is equal to 2 by 3. So R1 plus R2 itself is nothing but PA minus PB. So this is the answer to this question. So here we have used our knowledge that one of the point of intersection lies on one side of root 3, 0 and the other point lies on the other side. If both of them lie on the same side, both R1 and R2 will be of the same sign. So in that case, I'll get PA plus PB, something like that. So I hope this is clear. Thank you.